Greetings and a good day to you all. We meet again for the second lesson on data communication networks. So remember, last week we introduced the topic of networks, and we said a network is basically a connection between two computer devices or more. So today we are going to continue looking at the subtopic network topology. So before I talk about network topology, I want us to reflect a bit on what we talked about last week, and then so that we can be able to link it today's lesson, and then it becomes continuous. And then next week again we'll talk about another topic, and then hopefully that will conclude everything about computer networks. So last week we said a network is when we connect devices, and then we went on to look at the advantages of networks. We also looked at the disadvantages of network. So by networking, really we realized that the major idea behind the networks is connecting devices, and when you connect devices, it allows sharing of resources. So when you share, it becomes faster to do things, and it's sometimes cheaper. Although the major disadvantage now becomes on the initial cost. We say it is very, very expensive to set up a network because there are a lot of equipment that are required. There are also expensive materials, like we said, and then it is for that process to take place, it needs expertise. Right? We say it, for you to set up a network, you should know how to do it. So to hire such people, it's quite an expense. So when we are learning computer studies career-wise, you can choose to be what is called a network administrator and be responsible for designing these networks. And today's lesson is going to be very key in dealing with issues pertaining to designing or a structure of a network. We also talked about the different types of networks. I hope you still remember them. And then through my own research there, I think I found about 11. But what is key for you to know are the 4 that I gave you from last week. So what are the 4? We said number 1, we have a LAN, a local area network. And this one, we said it is confined to a building. We also talked about the wide area network, and so this one is the widest. And we're talking about connecting of connecting of LANs in different cities or even countries. So when you connect a LAN here in Namibia, and then you can connect it to another LAN probably in the same company in a country like the United Kingdom or the United States. That's one. And then we also talked about a MAN, which is the Metropolitan Area Network, where we say that this one connects within a region or a city. So when you make a connection within a region, that becomes your Metropolitan Area Network. And then the last one we talked about, of course, is the PAN, that is the Personal Area Network, where it is confined to the person, where you're connecting your own devices, maybe your headsets via Bluetooth, your phone to your computer. So this one is very, very small within your own personal, what I could call gadgets. So today we are going to talk about network topology. So without wasting much of your time, let's get to it. So as we've already said, the topic is network topology. Yeah, so remember, if you have any questions regarding any of my lessons, you are always free to ask. The number is there on the screen. You can call me, you can text me, even a WhatsApp message. I should be able to respond to any of your queries. So also my email, send an email about anything. So by definition, a topology refers to the layout of connected devices on a network. So this is the definition according to our own computer studies. But if you read further, you may find that topology has something to do with shape. But when we take the concept of topology in computer studies, we say topology refers to the layout. So the keyword is layout of connected devices on a network. So the layout is basically saying how the devices are connected on the network. Right, so there's basically these 6, or some say it's 5, but these are the different types of topologies that we have to learn about, that we have to know about, right? So there is what is called a mesh topology. There is what is called a star topology. There's also what is called a bus topology, and there's also what is called a ring topology, right? And then a tree and hybrid, they are used interchangeably. Some are able to differentiate the two. Some say it is pretty much one and the same thing, but there is a slight difference that I will demonstrate as we go through this lesson. So remember, topology is referring to the layout on how the devices on that particular network are connected in a diagrammic form when you talk about shape. So here, the first one, it's a bus topology. So by layout, you are saying those blue dots are representing the devices, or what I could call the computers in this scenario. So in a bus network, the computers will be connected in that order. And then we also have a ring network, which are connected in a series, right, in a circular form. The computers or the devices are connected together to form a series of connections. So each computer being connected to the next until you have the whole network. And then we've got a star topology, which is one of the most popular, where you've got a device at the center, and then we've got many different devices connecting to that device for services. Right, this one is also the popular one, even at home, where you have got maybe it's your Wi-Fi router there in the middle, and then these devices can be either your laptops, your desktops, or your smartphones or tablets connecting to that device. So that's a star topology. And then we have got what is called an extended star. So it's basically a star that will be connecting other networks as well. This one, it's just okay for you to know. And then we've got that one which forms the hierarchical form. As you can see, it follows the shape of a tree. This is the tree network. And then we have got a mesh. So basically, a mesh, it follows that it's an extension of the ring. So if you see a ring where the connections are in series, but in a mesh, besides that ring setup, the computers, even if they are not connected, even if they are not next to each other, they can be able to transmit data between them, right? So those are so when you talk about topology, we're talking about the layout. So these are the different types of layout. Let's look at the first one, the star topology. So in this one, each device has a dedicated point of link to a central controller called a hub, which is called an ACT, which acts as an exchange. So basically, we have got one link which all the devices are going to connect to. Remember, this one is the one that I say it is the most popular. It's the most common type of a network. So on this one, there is no direct link between devices. So I'm saying if we are connected to a star network, there is no direct link between devices, because all the devices are connected to a central point. The transmission occurred only through the central hub. So when device 1 wants to send data to device 2, first sends the data to the hub, which then relays the data to other connected device that all means. Let's see that in a diagram. So we have got a central point, right? So all the other devices are directly connected to the central hub. So what we were saying that you cannot connect devices like this device here on my mouse here where it's moving. If it wants to probably send data to this device, right, it has to send first to the central hub, and then the central hub will then send. So there is no direct link. So basically in a star topology, we have got that central hub, and then the connectors are connected to that hub. So transmission is through the hub. So the hub is the most important part, right? So this is how a star network, and remember I said this is the most popular and very, very common type of network, right? Right, so what are the advantages of using a star topology? Right, the first one, that it's less expensive since each device is connected to the hub, right? So it therefore means the installation and configuration is easy, right? There's less cabling needed. So you're saying what you need is a central location. It's a central hub. So what you're going to do is just to go and connect your device to that location. So you realize that it's very easy. It's like yourself buying a router at home, your Wi-Fi modem. So the only thing that you need is to connect your device to that particular router. So you can use it even wirelessly, or you can connect using a cable. So it's a matter of taking your device and then you connect it to the router. Right, and then the other advantage is what they call robustness, and I want you to get used to these words, right? So by robustness, it means it's strong, right? In the sense that if one of the devices fails, I'm saying all the devices that are connected to this type of network, if any device fails, the network will still work. Right. A typical example is when you're in the computer lab. You're in the computer lab and then your computer does not have internet, right? But that doesn't mean there's no internet. The internet will still be there, but it's only one device that is failing to connect. So if your device fails to work, it doesn't change that the network will still remain there. So it's a strong type of structure, right? And therefore it's very easy to identify problems on the network. Why? Because you when your computer is not connecting to the network, so you know that is the computer that is having a problem. And probably if now all the computers are not connecting, you know the problem is at that central hub. So it's easy to manage, right? So there are no disruptions to the network when connecting or removing devices. So if you want to add the device, you don't necessarily need to disconnect the entire network. It's a matter of just going to plug in your device or removing your device. Now, so let's look at the disadvantages of a star topology, right? There may be many disadvantages, but I'll be interested in talking about this one. The major drawback about a star topology is what we call dependency. So what it means is that the whole network is dependent on that central hub. Remember the central hub that we talked about. So if that part of the computer is not working, it therefore means that network is not working. Right? That is the problem. It depends solely on that central location. So that's why you see sometimes the bank the network is down. It's why it's because that central part, or where the devices are connected, it's not working. So if it's not working, it affects the whole network. So that's the major disadvantage of a star network. So let's look at where this type of network is commonly used. So a star topology is used in local area networks, and I want to believe that's not a new term, because we talked about it last week. So if you are seeing this video for the first time, go to our last week lesson to learn more about LANs. So they are used in local area networks. I've already given an example of a computer lab. So if you remember the structure of a computer lab, where you have your computers, they're in the computer lab, but they're all connecting to a central point, right, which is the switch right behind me, right? So all the computers will be connected to that switch. So that becomes the central point. That becomes the central point of that kind of thing. So high-speed LAN often used, and so sometimes it's about speed when we talk about star. So the next one is the bus topology. Right. So a bus topology is a multi-point, right? Here, one long cable acts as a backbone to link all devices that are connected by drop lines and taps, right? So in a bus topology, we have a cable, right? We have a long cable, and then your devices are connecting to that cable. So it is what is called a drop line and a tap. Those are the keywords. So a drop line is basically the connection between the devices and the cable. I will show you that one in the next slide. So the tap is the splitter that cuts the main link. It's called a tap, right? So this allows one device to transmit at a time, right? So let's look at what a bus network, a bus topology looks like. Like we said, we have got the main cable. We have got one main cable, and then we have got the different computers connecting to that cable, right? So basically how this works is that we've got a tape here, we've got a tape here. It's also called a terminator, right? So if this computer here wants to transmit data, say to this computer here, the last one, the first and the last one, so this computer will send its contents to the main cable, right? So when this computer has made access to this, so it means no other computer can transmit data until that data has been sent. So this data will go through this cable until it reaches this computer, and then the tape will open, right? So we said that we have the what you call the drop line, and then remember we said the drop line is the connection between devices and the cable. So we're saying this line which connects the device and the main cable is called the drop line. So the drop line is now used by the device to transmit data into the cable, and then the cable transmit that data to the required computer. So basically by bus network, we're saying the computers will be as follows. Again, you see how you have got your main cable there, and then your computers are connected in that way, right? So this is what a bus network. So the key is the main cable, and that now your devices are connecting to that table. Right, here's another example, a long bus. You see there you have a main cable, and then you have got your devices connecting to that cable. That's another example. There is your tape, and there is your, so the terminator where the table ends. So you'll see this computer sending data to this computer, so it will be sent through that cable. So it sends through the cable, right? So a device wants to connect with another, sends a broadcast message onto the wire for all devices, but only the intended devices accepts and processes the message. So basically we're saying when this computer wants to send data to this computer, so it has to communicate with this main cable. So once communication has been initiated, which means this main cable will not be doing anything until the computer is received. So all the computers are communicating with the main cable. The main cable is doing the transmissions, and then the drop line will receive the final information to the intended. So it means if the message is intended to this computer, it will not be received by this computer. It will not also be received by this. So a broadcast message, we are saying it's a message that is sent to all the computers, right? A broadcast message is sending. So the computer will broadcast a message that I'm intending to send information to this particular computer. So for this particular computer, it will wait to receive that message. But all these other computers will get a message say you are not receiving these messages, right? That's how a bus topology works. Now, what are the advantages? They say easy installation. It's easy to install. As you can see, when I look at the structure, you have got one main cable, and then you have these drop lines connecting to that main cable. Now, what are the disadvantages of using this type of network? The major one is difficult reconfiguration and fault isolation. Here we are saying because we are using many cables to connect to the main cable. If there is a fault in this network, it's very difficult to point out where exactly the problem is, because any of those parts of the network can actually disturb the entire network, right? So it's also difficult to add new devices. And then signal reflection at the top can degrade in quality. And then if any fault in the backbone, all transmission can stop. That's another disadvantage. So we are saying if this main cable breaks down, and then the whole network will not be able to work. So those are some of the disadvantages. So the next one is the ring topology. Here we have a dedicated connection with two devices. Each device has a dedicated connection with two devices on either side. So every device on this type of network, it has a computer connected on both sides, like the left and the right side. So the signals are passed on in one direction from device to device until it reaches the destination, right? So, and then to add or delete a device, it requires only two connections, and then we will see that. So this is a ring topology. Like we said, we have got computers connected in a series like that. So for every computer, it has two computers on both sides. There's interconnection between computers. And then we also say that when passing information, so this computer wants to pass information maybe to this computer, right? Because communication is in one direction, right? So it has to go through this computer until it reaches this computer. So that's why you see those two connections. So here we are, this computer transmitting message to this computer. So it starts from here, it goes to this computer, and then this computer will pass it to this computer, and this computer will pass it to this other computer. So what are the advantages of this network? Easy to install, easy to configure, and then fault identification is also easy. Why? Because if this computer wants to send message to this computer, right? So you just look at where the message is, and then you know that is where the problem is. So that's how you figure the problem. Then the disadvantages, the major disadvantage is that it's unidirectional traffic, because traffic flows in one direction, right? So if say for example this computer, right, wants to send information to the computer that is next to it, right, but because information is flowing in that direction, it has to go through this computer, and then through this computer. So if it happens that this computer is off, it means it may even take longer to pass a message. That's the disadvantage thing. Right, so a break in a single ring or in a single connection can break the entire network. Why? Because if any computer in this network breaks down, and then the whole network is messed up, because that computer is responsible for transmission of information. That's why it's right. So where do we see application? This one. Ring topologies are found in some office buildings or school campuses. Right, so today high-speed LANs made out of this topology, but it's no longer very popular. But some schools and some offices are using this type of connection. Right. The next one, let's look at a mesh. Right, a mesh is basically an extension of the ring topology. Right. Instead of having a dedicated direction, so in a mesh, you can have now computers being directly connected. So here, every device has a point-to-point link to every device on the network. Right. So that's the major difference. Right. The advantages now is that they use dedicated links, so each link can carry its own data load. So traffic problem is avoided. It is robust. Now, if any link gets damaged, it cannot affect others. Right? Unlike in the ring, we say when one device is down, and then it means the entire network is faulty. But this one, and then it offers privacy and security. Right? Why? Because in a ring, for a message to pass through to the last computer, it has to pass through this computer, and then it passes through this computer like that. But here, you can send a message directly. You see now, because now every computer is a direct link to every computer on the device. Right? So that's a mesh. It's just an improvement on the ring type of network. Right, so the advantages, we have already talked about that. So the major disadvantage now is because there are more cabling is required to make those direct. So for more devices around that network, it becomes much more expensive, because it requires more cables to connect those devices. Right, and the sheer bulk of wiring is larger than the available space sometimes. Right, so the applications of this one, they call the telephone regional office, and also in a wide area network. A wide area network uses this type. So you find in a wide area network where you've got computers connected at different locations. Instead of doing those relays, you need a direct connection. I mean, if you are in a region in Namibia, you want to connect to a region in the United States, so you need that direct link. That's where we see a mesh type of topology. Right. So now I'm not going to explain further the concept, as long as you understand it's how it is. What you're going to do now, you just take a pause on the screen, and then you take notes on the tree topology, what it's all about. But what's important is for you to understand the shape. Right, you see the shape. It follows a hierarchical structure, where you've got a computer, and then they're transmitting information. So you find the top computer will be the server that's connecting the devices. So in a tree network, it follows that structure, where you have computers disseminating or sending information following a structure. So this one is common in those type of networks where you want to do a concept called data hiding. what is called abstraction, or sometimes it's called it encapsulation. We're saying probably this computer belongs to the CEO, right? And then he sends information to the general manager of the company, and then the general manager receives that information, sends to. So you want to separate levels of access by cutting down on information. So information is going down. That's a tree topology, if I have to explain. And then a hybrid will obviously be the last one we talk about. So this one contains all the different types of topologies. So this one, you find it may use a combination of a ring and the star mesh. So it will combine these networks. For an example here, we have got a backbone here, which is the structure of that bus. So this bus is connecting a ring. You see now, you've got a ring connecting to that cable, or we can have a star also connecting that cable, and then onto that star you've got another star again here connecting to this bus, and then you've got this bus connecting to this bus. So you can have many different topologies. So they are called hybrid, right? So these ones I will be using. These ones may be used by those companies who want to. A company which is using different types of networks and they want to connect them together, maybe within the same building. Right. So the last one we are going to look is now what are the considerations for choosing a topology. So those ones in red are what you are interested in. First one is money. So when you're considering which topology to use, it's about money, right? So you want to choose the least expensive way to install a network, right? So another consideration is length, right? Or the size of your net. How many computers do you have? So they also work. And then you also have to consider the future growth, right? You want, obviously, when you are a company, or even at home, you want your networks to be expanding. You want to grow. So you want to make a network that is easy to add, depending on how much you want to grow as a company. And then also consider the cable type that you're using, And then talking about the cable types, when we talk about that equipment which is needed to build networks, we'll talk more about the different types of cables that are used. So the cable types that you can afford, they can also determine which type of network you use. For example, if you're using a twisted wire pair, which will transmit small amounts of data, then you can't use the bus network. So you would rather opt maybe for a star network. Those are some of the limitations that you have. So that is all for topology. Remember, topology is about the layout. Right, so now I'm going to give you an assignment that I want you to do. So the assignment is very simple. You go to Microsoft Word. I want you to draw the network structure you're using at home. So you can just do a simple sketch on Microsoft Word. But if you don't have Microsoft Word, what you can do, you now have to draw it on a paper, and then you take a picture, you send onto the system. I've talked about how to send work back into the system. So I want you to do this one. So when we meet again next week, we will talk about equipment that are required to build networks. That will be all for now. Right, so remember, it's about the shape. How do the devices in that network connect to each other? So for our next lesson, and now for our next lesson, we're going to look at the equipment that are required, what I would say the configuration of networks What are the equipments that are involved? So this one is it's a rather long topic or subtopic, which I hope I will be able to break down into one lesson. But if I feel like it's too long, I'll try to split it into two so that you can look at in sections. But I know if you have a good understanding of the topics we were talking about before, you should be able to connect, and it's easy for you to connect the equipment that you require to create a network. So before I go, I'm going to leave you with a small task. It's a very, very small task. What I want you to do, I want you to look at your setup right now at home. I'm sure there's a type of network that is going on. So what I want you to do, I want you to get into Microsoft Word. Right? I want you to get into Microsoft Word, and then you draw the architecture and the structure of all the devices that you have in house and how they connect. And then just below your diagram, I want you to tell me what type of a topology that which you presented is. So until we meet again, remember, keep on staying safe and study hard. Thank you.